Hello friends, welcome to yet another chemistry video from eLearn. My name is T-Man. Today we want to discuss paper chromatography. In this video, we discuss what is paper chromatography, how is it done, and how we interpret chromatograms. So, what is paper chromatography? Paper chromatography is a separation technique used to separate different substances dissolved in a liquid. These are often colored substances such as food colorings, inks, dyes, or plant pigments. Paper chromatography can also be used on colorless substances such as mixtures of amino acids. A locating agent is needed to make the spots visible. A commonly used locating agent for amino acid is ninhydrin. The information obtained is used to help identify the substance. So, how is chromatography done? First, we need chromatography paper or filter paper cut into a nice rectangular shape. We draw the baseline using a pencil. We cannot use ink for this because ink can be soluble in the solvent and will affect our results. We spot the paper with the substance on the baseline in the middle of the chromatography paper. We use a capillary tube for spotting the paper. Then we look for a tall beaker and place a shallow amount of solvent in the beaker. The solvent can be water, ethanol, a mixture of water and ethanol, or propanol. Any substance that would dissolve the mixture. After that, we put the chromatography paper in the beaker. Care should be taken to ensure that the baseline and sample are not submerged in the solvent. This is why we need a shallow amount of the solvent. If the sample is submerged, it will dissolve and go into the solvent and no chromatography can be done. Next, we place a lid on top of the beaker, and then we allow the solvent to rise up the chromatography paper by capillary action. After we have given the solvent front enough time, we then remove the chromatography paper from the beaker and allow it to dry. Once it's dry, it is time to interpret the chromatograms. So how is this done? The first thing that we do with our chromatogram is to draw a solvent front. This is also done using a pencil. The first interpretation that we do is to check the number of spots that are produced on the chromatogram. In this case, we have 3 spots, which tells us that we have 3 substances. Next, we calculate what are called RF values for each of the spots. An RF value is simply the distance moved by the spot divided by the distance moved by the solvent front. So what do we do? The first thing is to measure the distance from the baseline to the solvent front. We need a ruler to do this. You can see in the diagram, I have a ruler, and this reads 4.5 centimeters. Next, we measure the distance from the baseline to the midpoint of each spot. Let's start with the green spot. Using our ruler, we see that the distance here is 0.6. We calculate our RF value, which is 0.6, distance moved by the spot, divided by 4.5, the distance moved by the solvent front. And this is going to give us a value of 0.13. Let's go to the blue spot. We need our ruler again. The distance here is 1.7 centimeters. We follow the same drill. RF is equal to the distance moved by the spot divided by the distance moved by the solvent front. Our spot moved 1.7 centimeters divided by the 4.5, and this gives us 0.38. We move on to the red spot. We bring our ruler again and measure. In this case, the distance is 3.8. We follow the same algorithm. RF equals to 3.8 divided by 4.5, and this gives us a value of 0.84. Now, as you have seen, the RF value is always between 0 and 1. If the RF value is 0, it is of no value because it means the substance does not dissolve in the chosen solvent. And if the RF value is also 1, it also means it is not of value because it means it has no adhesion at all to the chromatography paper. It is no good. Next up, we then use the RF value to identify a substance. Now, how is this done? We compare the RF value that we obtain from tabulated values of RF values. Next, we continue with interpreting chromatogram. There is a special way of analysis that uses reference substances. Now, reference substances are pure samples rather, of known substances. The chromatography paper is spotted with the unknown substance and the reference standards side by side. And then the chromatography is allowed to run. The spot or any spot of a reference standard that aligns with the spot from the unknown indicates the unknown contains the reference. In this case, the unknown X contains A and C. As you can see, for the red spot in X, it aligns with A. And the blue spot in X aligns with C. But X does not contain B. Although B is also green, it does not align with the green from X, so it means X does not contain B. So in this analysis, this can be used to check if food, for example, is having banned substances like dyes and such analysis. Thank you so much for watching what we do from here. As always, we like the video, and if you have not subscribed yet, please subscribe. Click on the notification bell so that when we give out another video, you don't miss it. Please also share if you like the video so that more people can enjoy. Bye-bye for now.